All right, everyone, can you hear me clearly?
Yes, we can hear you clearly.
Yes, yes.
Okay, that's good. So I will go through the lecture today. So once again, in the first week, we covered the basics of computer hardware. Then we talked about computer software in the second week. And we saw this diagram here, and that shows that how the application software and system software interacts with the hardware. And then we saw that the system software, it has various types. We have the main system software, which is the operating systems. Then we have the system utilities, which have limited access to the hardware. And then we also saw device drivers, which basically help the operating system in order to communicate with the hardware. I give you an example also where if an application, for example, Microsoft Word, you are writing any text in Microsoft Word, and when you issue the print command, the application will not directly go to the hardware. The request will be sent to the operating system, and then the operating system will use the device drivers to communicate with the hardware, and the hardware after that, the printer will basically print whatever document you want to print. So this is how the communication between the hardware and the software works. Any question related to this that we covered last time?
No,
Is it okay?
thanks.
Okay,
It's all clear, Mr.
okay, that's it. So once again, just to revise, the operating system, it basically controls the system's hardware. It also manages and interacts with the running application software, and then it provides a user interface. So what is, first of all, let's see, what is a user interface? Any idea? All the students, you can give any answer. So what do you think is a user interface?
The user favorite settings.
Uh, User interface is basically how we, for example, we communicate with the software, how users interact or communicate with the software. That is called a user interface. So user interfaces, they are basically of two types. So user interfaces, they are of two types. We call them GUI and CLI. GUI stands for graphical user interface. And then we have the CLI, which stands for command line interface. So the first one, the graphical user interface, just like the name suggests, in this type of interface, the user will interact in a graphical manner. For example, there will be graphical icons that I can interact with using touch input, using mouse input, or using sensor-based input. So I can interact in graphical manner. That is a graphical user interface. In case of a command line interface, what do you think will be a command line interface? This type of interface is where the user will interact using commands. By commands, that means you have to type on the keyboard whatever you want to interact with. So that is two types of interfaces that we have. Now, one question that I have right now is that you see here the users, we interact with the application software. So what type of user interface do you think we normally use? Graphical user interface or command line?
Command.
No. You see right now, for example, if I'm interacting with PowerPoint, so there are different icons. I am communicating through the mouse. I can also use the touch input if my screen allows it. So this type of interface that we have, that is a graphical interface. I will show you later what a command line interface looks like as well. So most of the softwares that we have, we interact with them using a graphical interface. Now, another question is, in this diagram, you notice the user is interacting with the help of an interface to the application software. Do you think users, we can communicate directly with the operating system? What do you think?
No, you can't.
Yes, the answer to that one is also yes, we can. For example, here right now, I'm communicating with PowerPoint. So I'm communicating with an application software. But if I minimize everything and let me go here. So this area, so what is this here?
Desktop.
This is the desktop of Windows, right?
Yes.
So am I communicating directly with the desktop of the Windows?
Yes, you are.
Yes. So basically, yes, we can communicate directly with the operating system as well. So that is another type of communication that we have. So once again, we talked about system utilities and the device drivers, and these were the different type of application and system software that we have. The most important one was the operating system. So in the operating system, this is where we stopped. This diagram is the very important one where we have the users. We can communicate directly to the application software. We can also communicate directly with the system software, just like we saw. For example, in your smartphone, when you are accessing iOS, for example, before you open any application, before you open WhatsApp, at the home screen, when you are interacting with the icons, that is a graphical interaction with the operating system. So users, they can communicate directly with the system software. We can also communicate with applications. Applications can communicate with users. Applications can communicate with system software. But notice only one of these three can communicate directly with the hardware, and that is only the system software. So system software can control, can manage, can communicate with the hardware resources. Users, they don't have direct control of the hardware. Applications, they don't have direct control of the hardware. Do you understand this diagram, everyone?
Yes, clear.
Yeah. So now, if you talk about the interfaces, just like I told you, in a graphical interface, you interact using mouse, using touch input, using visual input. There are icons you can use to communicate graphically. But in a command line interface, what you see is like a black screen. And whatever you have to do is you have to type commands for that. And the result you will get back, that will also be in text form. This type of interface was used in very early operating systems. In the 80s, we used to have an operating system that was called DOS. DOS stands for Disk Operating System. In this DOS operating system, whatever you have to do, you have to write commands. And that's how we interacted with the operating system. So these days, once again, if you talk about the operating systems now, so which interface is popular in the operating systems these days? It's mainly the graphical user interface. Your Windows, your iOS, your Android, all these operating systems, they are using the graphical user interface. But all of these operating systems, they also have the command line interface inside them. For example, in case of Windows, in the search menu here, if you type CMD, it will show you this option that is the command prompt. So if I open this one, so what is this? Anyone, can you tell me what is this one?
CLI.
This is the CLI, the command line interface of Windows. So here, whatever I have to do, I have to type commands for it. So for example, I want to look at the directory contents, I will type dir. If I want to look at the IP address configuration, I will type ipconfig. So here I can look at the different IP configurations that I am getting. So, but the idea here is that whatever I want to do, whatever interaction I have to do, I will have to do it through commands. You get my point?
Yes.
So that means we need to memorize commands in order to communicate. So which one of these two, command line and graphical, which one of them do you think is more user friendly?
Graphical.
Graphical, of course, right? So graphical interface is very friendly. That is why it is very popular. But the question is now, why do we still keep the command line interface? Why not just completely get rid of it and just use the graphical interface? Why do you think we still have CLI?
Because we can't use graphical without commands.
Exactly. We can't use graphical without commands. And basically, the main reason why we keep the command line interface is that it is still very powerful. If we run into any trouble, if we want to troubleshoot the Windows, if we want to fix things, we still use the command line interface. So if you want to, for example, if your Windows gets corrupted, you can use the command line interface to run various commands, and then you can use it to fix the operating system. So that means the command line interface is difficult, yes, but still very powerful tool to interact with the operating system. That is why most of the operating systems, they still have command line with the operating system. Graphical is, yes, it is friendly, but we keep the command line as a backup. Is it okay, everyone?
Okay.
Okay, so the last thing before we go to the next lecture, so that is the modules of the operating system. So operating system, I told you, that is operating system is what? It is simply a resource manager. This is the full definition of operating system, but if I want to define it in 2 words, an operating system is a resource manager, agree? And resource basically represents your hardware. So your hardware are basically your resources. So my question is, do you think we have one resource or do we have multiple resources?
Multiple.
Multiple, right? We have the processor, we have the storage, we have the RAM, we have the graphics card. All of those are our resources. So in operating system, what we do is we divide the work into what we call a functional units, which are called modules. Each module is responsible for managing one hardware resource. For example, my processor is a hardware resource. To manage the processor, I will have a processor management module. My RAM, my memory, is a hardware resource. To manage this, I will have a memory management module. Similarly, I have my storage devices. To manage them, I will have disk management module. Similarly, to manage my files, I will have file management module. What do you think will be the purpose of file management module? It will be simply to basically cut files, create new files, copy them, delete them, remember their location. Everything related to files will be under the file management module. So do you think, have you seen file management module in Windows? What do you think? Anyone? We use it all the time. This file management module.
Maybe
Yes.
task manager, Doctor.
The task manager, no. The file management module basically is your, this one here. This is the file explorer, right? So here, can we use this to create new files? I can create new files here, right?
Yes.
Yes. Can I cut the files? Can I delete the files? Can I rename them? Yes.
You can.
So I can do everything related to files here in the File Explorer. So File Explorer is basically our file management module. Similarly, disk management module of Windows. For example, disk management here, you see on the right, on the start menu, if I right click, disk management module, you can control different storage devices and their partitions here. I can create new partitions, I can shrink or extend the volumes as well. But don't play around with this one, especially. You may end up formatting the drive. So make sure you have full control before you start playing around with the disk management module. Similarly, we have memory management module. What do you think is the purpose of memory management module? Any idea?
To control the capacity of the RAM, maybe.
To control the free space of the RAM, basically. What does that mean? Now notice I told you whatever application you are running, it will be in your RAM. Agree? Remember in the first week, I showed you this diagram where I told you whatever application you are running, it's in your RAM. And also the operating system is a software. That means it is also in the RAM. Agree? If operating system is in the RAM, that means all the modules of the operating system, they are also in the RAM. So now in the first week, I showed you that if I want to open Word, I will bring the whole Word application into the RAM. Do you agree, everyone?
Can you repeat it, Mr.?
I told you that in first week, I told you if I want to open an application, I will bring it from storage into the
Yes.
RAM. Yeah, but I did not tell you where in the RAM should I put the Word application. Should I put it here? 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 Where should I put the Word application?
Does it make a difference, Mr.? Or it's
I
like
think,
Of course. For
closer
example,
to the processor.
what if I put the Word application here and operating system is already loaded into this area? What will happen? It will override the operating system. You see the problem?
Maybe closer to the processor.
Now, the whole RAM is closer to the processor. The idea is that in the RAM, there are other applications. There is Windows also inside my RAM, right? I don't want to put my new software in a place where there is already some other application or operating system there, right? So what happens if I want to load Word application? I will not directly load it. I will first go to the RAM. In the RAM, there will be the memory management module of Windows. I will first request that I want to load the Word application. The memory management module will tell me that, okay, the free space in this is in this area. So then I will load my applications here. So this control of the free space inside the RAM, this control of the free space, where is free space, where the new software should be loaded, all of that is under the control of what we call the memory management module. So this here inside the processor, we have this one, which is called the memory management module. It is responsible for loading applications into the RAM, also removing the applications out of the RAM. Similarly, we will have processor management module. Whenever applications want to go to the processor, it will be managed, it will be controlled by this module. So you get my point, everyone, about the modules?
Yes, Mr.
Yes, clear.
So that was the basic of operating system. So you can read through the remaining one. This is very simple, open source and close and general public softwares. So what I will do now is that I will start the second topic. But before we begin, we have an announcement. First one, that is quiz 1, which will be in week number 5. That will be from chapter 1 of the lab manual. So this is week 3 after the next week. So next week is week 4. So in week 5, we will have the first quiz from chapter 1 of the lab manual. And that is week 1 and week 2 material. It will be during class time, and practice questions are at the end of the chapter. Secondly, I will go through the practice questions which are at the end of the chapter in tomorrow's help session from 11 onwards for male students. So if you want to attend, you can reply to the email that I sent you this week for the help session. So I will just go through the questions. They are very simple. If you can do it by yourself, that's fine. If you need help, you can come to the help session as well. Just reply to the email. Secondly,
Doctor?
yes. Next question.
Yes, Doctor. Can I leave because I don't? My network is bad actually.
Okay. I will post the video, so you can also check the video from there. Okay?
Okay, will you take attendance?
Attendance I will take from the class session, from the video, no problem.
So will I be marked as attendance?
Yeah, okay, no problem.
Okay, thank you.
Mr. I
Doctor,
have another question.
I was late.
It's okay, it's okay. I will just check the attendance from the class session. Don't worry. Okay?
Mr. I have another question.
Yes.
What if I have a class conflict with the help session class time?
And then you can come in the break time from 12 to 1. You can come also. You can
Okay,
ask
no
me for
problem.
that time. Okay, just tell
Okay,
me in the
thank you.
email. Yes, yes.
Thank you, no problem.
Any other question? There's someone who's raising hand. Yes, Muhammad Zafar, you have any other question?
No, thank you.
Okay, so this is for quiz 1. Secondly, the presentation 1 that will be in week 6, but most probably it will be shifted to week number 7 because I think you have a math major exam in week 6. The dates are going to be finalized soon. So if there is math exam in week 6, in that case, the presentation will be shifted to week number 7. But before the presentation, what I want all of you to do is to create groups. Try to create groups and send me before the next class your group members. It can be 2-member group or 3-member groups. Just send me the list of groups that you have, and what I will do is I will mark your groups. If you are not able to find any members, in that case, I will allot the group members by myself randomly. So make sure you create the groups. Secondly, for the topics for presentation 1, I will give you in the beginning of next week. So what you will do is each group, you will select 3 to 4 topics from the list, and I will assign you one of those topics according to the priority. So you will select top priority number 1, number 2, number 3. Just let me finish. And based on the availability, for example, if you submit early, then you will be given the first priority. So make sure you submit the presentation topics as early as possible. Now, if you have any question, you can ask. Yes.
Doctor, where should I send you the list of the
Group
team
members?
yes.
Just send me on my email. You know my email, right? mohsinbhat@kfupm.
Okay. Can I send you also on Teams?
Better through email because I'm keeping track of the group members from there. Okay.
Okay. Should I include the student ID?
Yeah, student ID, your name, and the section. That's
Okay. Thank you, Doctor.
welcome. Any other question related to these two?
Yeah, Doctor, for each group, we will have one topic.
Yeah, for each group, we will have one topic.
Okay.
Okay. We cannot repeat the topics in the presentation. That is why whoever sends me the list of presentation topics first, you will be given the priority. Okay. Otherwise, if you send the topic late, then whatever topic is left will be assigned to you. You get my point, everyone?
Yeah, okay.
Yes.
Okay, so let's continue then. So today we are going to talk about the basics of computer networks. What are the different network devices? Mainly, we will focus on the router and we will see how the internet works. And then next week, we are going to talk about cybersecurity, what are the different threats, and very important part in that one next week will be the encryption and hashing techniques that we will cover. So a network, like I told you in the first week also, a network in just like in real life is a group of people who are able to communicate with each other, that are able to exchange information that creates what we call a network. If I say someone has a good network also, that means he has good communication skills, he has good communication friends as well. So just like the same idea, we can translate it into network of devices also. So if I have a group of devices that are able to communicate with each other, that creates what is called a communication network. So once again, a communication network, we can have any type of devices in a communication network. Now, what is the meaning of communication in terms of digital devices? Any idea? What does
Maybe
communication mean?
sending and receiving.
Sending and receiving information. Agree? So this information that we send and receive, it can be text, it can be video, it can be audio, it can be web pages. So there are many types of communications and many type of devices that we use for communication. So based on that, we have many types of communication networks. So communication network, you can say it's like the main term that we have, that is communication networks. And these networks, they are of many types. If the devices we are using are your mobile phones, we call that the mobile networks that are a type of communication network. Similarly, in the banking system, the ATM machines we are using, that creates what is called the ATM network. And the same idea, we can have sensors that are able to communicate. We call them sensor networks. So there are many types of communication networks. One of those type is basically your computer network. So computer networks, if the devices that we are using for communication are your computing machines, in that case, we call that computer networks. You get the idea? So in a computer network, once again, the main devices which are used for communication are your computer systems. Now, another question, do you think, is there a possibility that we can exchange information between these networks? Can computer networks send information to the ATM network, or mobile networks, can they communicate with computer networks? What do you think?
Yes, they could.
Yes, of course. So there are devices which we can use for inter-network communication as well. But right now we will mainly focus on the computer networks, in which the main devices we are using, those are basically computing machines. So in a computer network, the main information that we want to exchange is divided into small chunks, which are called packets. So if we go into detail, first we need to define the very basic terms. We have, first of all, a source. In a small network, for example, if this computer wants to send some information to this computer, then the one who is starting the communication, that computer system will be called the source. Similarly, for example, if I want to open any particular website, if I want to go to Facebook or Instagram or Gmail, so in case of Gmail, I am the one who is starting the connection request, right? So if I'm the one who's starting the connection request, that means I am basically the source. Agree? Then similarly, if I'm requesting some information from Gmail, that means Gmail will be our destination, that is the receiver who will respond to the request. So we have a source, we have a destination. Then we have another thing which is called communication link or link. It is also called or channel. So what is a link or communication link or communication channel? That is how we interconnect two devices. For example, I have one desktop computer and another desktop computer. I want to connect them together. How can we connect them? Any idea? How can we connect the devices?
By the cables or
By cables, we have Ethernet. We call them the Ethernet cable or the Ethernet LAN cable. Let me just show you. So for example, these cables we can use to interconnect the two devices together. Is this the only way to connect the devices? The connection can be wired or it can be wireless as well. So for example, I can use Wi-Fi to interconnect them. I can use Bluetooth to interconnect them. I can use fiber optic connection also to connect the devices, right? So these connections between the two devices, that creates what are called communication link or channels. What do you think is the difference between these different channels? For example, what is the difference between computers connected through, like, let's say this Ethernet cable and the computers connected through Bluetooth? What will be the difference between the two?
Speed of the wired will be faster than the wireless.
Exactly. That is basically we can send more information. That means some links can carry more information compared to other links. So we see that from source to destination, the devices are connected using links. And if I want to go from source to destination, I will have to go through what is called a path. So what is a path? Path is a collection of links that will connect the source to the destination. So if I want to go from this computer to this computer, I will go through different links. The links are indicated by these lines in the network diagrams. So the collection of links that connect source to the destination, that is basically called a path. So do you think we have one path or do we have multiple paths available from source to destination?
Multiple, maybe.
Multiple. Which one we should choose?
The closest, or
The closest or basically the fastest one. You can actually see also, if I run this command here, let me see, that is trace rt space, let's say amazon.sa. So this command, for example, the trace rt command, what it will do is it will trace the path from my computer system to this destination website. So here I am the source, this is my destination. So my computer will go through different links, and notice the links, they are indicated by these different addresses here. Do you notice that, everyone?
Yes.
So here, once again, these are different links that we will encounter, and notice their addresses. Their information is in the form of numbers. So we will see later on what these numbers represent and how we can intercept, how we can understand what these addresses are. But anyways, when we go from source to destination, we have to use a certain path. Now, how the information travels in computer networks. So there were two methods which were used for information to travel. One was called circuit switching. The other one was called packet switching. So circuit switching, that was an old method to transfer information from source to destination. In circuit switching, the first step we did was to reserve a path, or you can say make the path private. What does that mean? Any idea? What does reserving a path or making the path private mean? Any idea? Okay, I'll let you know. So what is reserving a path? That means in circuit switching, if I want to send information, let's say from this computer system to this computer system, first, before I can send my information, first I will have to find a path. If let's say I decide on this path, that is, I go straight down and then I take the right. So if I decide that I will use this path, what I will have to do is I will have to reserve it. Reserve it means what? Reserve it means that no other device can use the links that I am using on the path. No other device will be allowed to use these links as long as I'm using my communication. So by doing that, what do you think? Is this a good approach or bad approach? By reserving the path.
Good approach.
Good approach for me, yes. There is no interference. I can send as much information on the links. Agree?
Yes.
But what can be the issue in this one? Any idea? Think of it in this way. Let me give you an example. Let's say the links, let's say the links are your roads in real life. Let's say the roads, they interconnect different locations, right? So let's say you are here in KFUPM, you want to go to Khubar. This is Khubar area, and there are many intersections. The intersection, think of them like signals, and these lines represent the roads. So what circuit switching says that if I want to take my car, my packet from KFUPM to Khubar, the first thing I will do is reserve the road itself. When I reserve the road, only I can drive on the road. Is this good for me?
Yes, it is.
Yeah, it's very good for me. I will not have any car on the road. I can drive as fast as I want, no problem. But what do you think for the overall utilization of the network, overall usage of the road? What do you think? Is it a good approach or no?
No.
No, because my road is designed to carry a lot of cars. Similarly, the links are designed to carry a lot of information. When I reserve the path, I am not using the links on the path efficiently. You get my point? So that was the old method which was used in, especially in the telephone networks in early days, landline telephone networks, they use this type of method. So later on we shifted to, which is used these days in computer networks, in mobile networks, in most of the networks, we use packet switching. In packet switching, what we do is whatever information I want to transfer, I will divide it into packets and then I will send them on the network. But this time I will not reserve any path. I just tell the packets, okay, this is your destination and you can choose any path you want. But most important part in packet switching is that different packets from sources, they can share the communication channel. When they share, what will happen? What do you think? When I'm sharing the road, what will be the advantage?
Maybe
We
could be
can
fast.
send more information in this
Same time, exactly. So the overall utilization of the network will be very good, right? So this is the same idea written here. That is, the stream of packets will take the optimal advantage. It will take, you can say, full advantage of the carrying capacity of the channel. Carrying capacity means how much information we can send on the channel. Or you can say the carrying information of the road, how many cars we can put on the road. So when we share the links, the packets will take the full advantage of the road, you can say. So by doing that, we are utilizing our network more efficiently. But doing that will also have some disadvantages also. What do you think are the disadvantages of doing this?
It will be a little slower.
Slower, how?
Maybe it's different paths, not one path.
Yeah, it can be. Okay, yeah, it can be one way because we are going through different paths, but we can solve that using a window size method inside the packets, but I will not go into detail. But one very basic problem is security. What do you think? Which one is more secure, this one or the circuit switching?
No, this one is more secure.
How? In circuit switching, remember, we made the path fully private, right? No one else was allowed to enter our path. Remember that?
Yes, the circuit is more private.
So that means it was more secure. But here we are sharing the links, right? When we are sharing the links, what happens? Sometimes maybe there is a hacker node here and it can capture my packet here in the middle. If it captures my packet, it can basically see what is the information inside the packet. So if it can capture the information, how can we protect the network? How can we protect from this problem?
Maybe encrypt the bucket.
Encrypt, basically secure the packets to make them more secure. So how we secure them? Using a method which is called encryption. We will see that later on, that the web pages, they use what is called SSL encryption. You may have seen when you are accessing websites, you see in the beginning, you will see HTTPS. For example, here, I'm not showing the full path here. So here connection is secure. It is using basically HTTPS in the beginning. So some websites, they use HTTP, some websites, they use HTTPS. So what does S represents? That means the packets, before we send them on the network, they are protected, they are encrypted, so that even if someone captures my packet, they will not be able to open them. You get the idea?
Yes.
So this is how we can solve the security problem. But is there any other problem we can have in packet switching? Just like in real life, think of it like the road. When we are sharing the road with other cars, what is the most common problem we have?
Maybe traffic.
Accidents.
Traffic jam, exactly. We have traffic jams also, right? So traffic jam in computer networks, we call that congestion. We call that network congestion. That is the traffic jam in computer networks. How do we solve it? Just like in real life, let's say in real life, let's say I'm here, this is KFUPM, this is, let's say, Khobar. When I am in KFUPM, let's say I decided I will go out, and from outside, I will take, from the signal, I will take the highway straight to Khobar. But when I reach outside, if I notice that, okay, on the highway, there is a traffic jam, what will I do?
Change the path.
Change the path. This is why exactly we do not reserve any path in packet switching. We let the packets go through any path they want depending on the network condition. If this link is congested, the packets will change the path. You get the point, everyone?
Yes.
So congestion we can also solve. So this is the most popular method which is used in computer networks to transfer information. Now, what are the types of computer networks that we have? So mainly, there are many types of computer networks. We will just discuss few of them. First, we will talk about based on how you manage a network. So based on management, we have two types of networks. We have client-server network and we have peer-to-peer network. In client-server, this one is very simple. What we do is, if I have group of devices, and what I do is I choose one device and I put all the information of the network in one central device, which is called the server. And any other computer, if they want information, they will have to request this information from the central device, that is the server. So all these other computers, those will be called the clients. And this creates what is called a client-server network model. So we call that a centralized system because all information is in one center point, and the clients, whenever they want some information, they will have to request it from the server. Where do you think we use this model? Any idea? Can you give me example? Where?
KFUPM portal.
KFUPM portal, yes, you can say that KFUPM portal uses this. Think broader. Think about the internet. You use websites all the time. Do you see any client server model there? What about Facebook, Gmail, Google websites? What about those? What do you think? They are using which model? Client server model?
Yes, they have servers.
Yes, exactly. The same idea. What they are doing is, for example, Instagram, Twitter, or Facebook, their clients, they are not just 6 clients, they are millions of clients, right? All your information is in the central Facebook or Instagram servers. Whenever you want that information, what you do is you provide your login ID and password to get access to your information, which is permanently on the servers. Do you get my point, everyone?
Yes.
So basically on the internet, almost 95% of the websites, they use the client server network model. The clients are spread throughout the world. Whenever you want some information, you will have to request it from the server. So this creates what is called a centralized system. And the biggest advantage of centralized system is it is easy to implement security for the network. How? Remember, security for the whole network. Imagine you have, let's say, 10,000 clients instead of 6. Let's say I have 10,000 clients and all their information is in one server. So to protect the whole network, should I focus on all the 10,000 clients plus the server, or should I just focus on the server only?
Only the server.
Only the server. So that's why we say it is easy to implement the security for the network. But this advantage can turn into a disadvantage also. How? How can this become a disadvantage as well?
If
Maybe
we hack the server, we can reach all the information.
Exactly. So this type of networks, we say they have what is called a single point failure. Single point failure means that inside the network, there is one device. If that device goes down, which is here in this example, which is the server, if somehow the server shuts down, the whole network will be lost. Agree? So how can we solve this? How to protect? One, yes, we should have very good security. What else can we do for the server?
More than one server.
We should have more than one servers to avoid single point failure. We call them backup servers. So we should have backup servers in order to fix this type of problem. So this is still, once again, the most popular network management method which is used on the internet. Similarly, we have another one which is called peer-to-peer network. So this is the opposite of client server. Client server was a centralized system. This is decentralized or distributed. That means there is no central command. The information is shared between all the devices of the network. Everyone will have the information. There is no one computer system that contains all the information. The information is shared with everyone. So when we have situation like this, what do you think? The security will be easier to implement or difficult?
Difficult.
Difficult. Imagine I have 10,000 devices. They are all interconnected. So it will be very difficult to provide security in this type of network. But do you think this type of network will have single point failure?
No.
No, because information is shared with everyone in the network. So even if this computer shuts down, no problem. Other computers have the information. If this computer shuts down, other ones have the information. The network will remain active. So this type of model, this was used in basically torrent networks. It's very popular, where you share the files between the different peers of the network. Another very popular use of peer-to-peer network, which is gaining more popularity, is the blockchain networks. This one we will cover probably in week 5 or 6. So blockchain networks, they basically solve the problem of security in the peer-to-peer network. Remember, I told you in peer-to-peer network, having all these devices interconnected, it is very difficult to provide security, right? So what blockchain will do is we will do some different cryptographic techniques, encryption, hashing, mix of those to basically secure the whole network. Once we can secure the network, then it will become very useful as well. So the peer-to-peer networks, they are used in torrent file sharing, but they are also used in blockchain networks as well. Any questions so far related to these two? Client server and peer-to-peer networks. Is it okay,
No.
everyone?
Very clear, yes.
All right, so next, let's talk about another type of networks based on the size of the network. So this is very simple. The small networks within a very small local area, for example, inside a home or inside a lab, those networks are called local area networks. And many local area networks, they join to make bigger networks. For example, the network in KFUPM, for example, in building 57 lab, we can combine the computers to make the network for the lab. That is a local area network. Now, different labs combine to build the prep year department network. That is a little bigger network. Prep year department network combines with other departments like computer science, like electrical engineering, and ITC departments. So all of these networks combine to build a bigger KFUPM network. Similarly, many bigger networks inside the kingdom, they combine to make the whole country's network. So if we keep on combining like that, we get what is called a wide area network. They cover large geographical area and they contain many small networks inside. The best example of wide area network is the internet itself. How can you define internet? Anyone? What is internet?
It's a wide area network that connects
It's a wide
many.
area network. It's basically, you can say internet is basically a network of many small networks throughout the world. They all combine to build this very large network that is the internet. So that is local area network and wide area network. Now, the devices that we use on the internet, on the computer networks, there are different types. We will discuss just mainly, we will focus on the router. But first we have what is called a network node or host or endpoint device. So those are the devices which are used to connect to the network. For example, here in my home, I have my home Wi-Fi network. So I'm connecting to this network using my laptop. I can connect to this network using my smartphone, using my desktop computer, using printer. So all these devices, they are called your network node or host or endpoint device. Very simple. Is it okay, everyone?
Okay.
So
Yes,
next,
Doctor.
this is the important one now. So next we have, that is our router. So this is the most important device in computer networks. A router, it has multiple tasks. The first task of a router is to manage and build a network. For example, if you get a connection from STC, so what STC will do is at your home, they will come and install a small device. That device is responsible for building your home network. So that device is basically the router, it is responsible to create your home network as well. So that device is basically your router. Once again, you can get access to the router also. So for example, here, let me check what is the IP. So let me show you. So here, once again, this is the settings of the router that is provided by the STC network. And once again, this router is responsible for creating the local area network that we have in my house right now. So this local area network is controlled and managed by this router device. Okay. Now, second and most important property of the router is to interconnect the networks. I told you here that many small local area networks, they combine to build bigger or larger networks. So for example, I will show you this diagram later also. For example, in the KFUPM, we have a prepare department, ICS department, electrical, mechanical, and mainly is our ITC department. So how can we connect these networks together? To connect the networks, we use basically the router device again. So one, it is responsible for creating networks. And secondly, it is also responsible for interconnecting different networks together. Do you understand the point, everyone?
Yes.
Okay, so the router is the one which is responsible for interconnecting the networks. And remember, internet is what? Network of many small networks throughout the world. They are interconnected. And who is interconnecting these networks? The router is the one which is the backbone of these interconnections. So the network level routers, they can interconnect many networks together. The network router that you get from STC, how many networks they can interconnect? What do you think? The router that is at my home or your home, how many networks do you think it can interconnect? Any idea? It can only interconnect two networks. That's it. First, the router is responsible, that one at my home, this one is responsible for building my home network. And then this home network, that router is connecting my home network to the STC network using the fiber cable. So it's only doing interconnection between two networks. So the basic routers, they can do interconnection between two networks, but advanced network level routers, they can interconnect multiple networks together. You get my point, everyone?
Yes.
Okay, so that is another property, but still, this is not the main property of the router. The term router, it comes from the word routing information. It comes from the word routing information. And the diagram that I showed you here, where the packets go from source to destination, these circles here basically represent routers now. Because remember, if I want to go from source to destination in the diagram here, you see, in the traceRT command here, my packet had to travel through different networks in order to reach the destination. That means who is interconnecting these networks? Who is interconnecting the networks? Once again, the main device which is interconnecting is still the router. So the packets, they will travel through these routers. But the question is, how can packets reach the destination? That is where now the routers come into action, the main property of the router. To get the information, first you need to understand the packet itself. The packets itself, it's a very small, basically you can say, the packet, what does the packet contain? A packet contains data inside, and then the packet contains, after the data, a packet contains what we call address. We will see how we can write these addresses. So packet contains data and address. That's it. This is what a packet is. So when I make the packet, I give this packet to the router. The router will look at the destination address. It will see that, okay, you want to send the information to Gmail, to Amazon, to Facebook. So based on the address, the routers are responsible for finding the shortest path to the destination. So it's basically the routers which are responsible for routing the information. The packets itself, it's just data with the address of the destination. So the routers, what they do, they look at the packets. Inside the packet, they look at the destination. Okay, you want to go to this location. The router will find that, okay, this is the shortest path. This router will check what is the shortest path. It will say, okay, go in this direction or this direction or this direction. So this process of finding the destination, this is done by the router. And this is the main task of the router, that is to route information. So these routers, they can be wireless, they can accept wired connections as well. So they have three main tasks. They can manage or create the networks. They can interconnect the networks. And third, most important one, they are able to route the information. They are able to find the shortest path to the destination. Is it okay so far?
Okay.
Any question related to the router? Is it okay?
Yes.
Okay, so these are the hardware devices that I talked about. Besides the hardware devices, now what is the software that runs on these hardware devices? That software is basically called the communication protocols. What does the word protocol mean?
Maybe guidelines and rules.
Guidelines, rules, just like in Corona, for example, during the COVID times, we had to follow certain protocols. If I want to go to the mall, I have to wear the mask. I must be vaccinated. I must show that on my mobile phone to the guard there. So that was the protocol, the rules that we were following, right? Similarly, if I want to send information from source to destination, I have to follow certain rules as well. So those rules for communication, for transmitting and receiving the data from one network device to another, those are basically called our communication protocols. And these protocols, they are of many types. The protocols, they will change depending on the type of communication, depending on the type of devices also. For example, if the two computer systems are connected through a Wi-Fi connection, they will use a certain protocol. Similarly, if they are connected using, let's say, a wired and Ethernet connection, that will follow a different protocol. If they are connected through Bluetooth, it will follow a different protocol. So depending on the device or how they are interconnected, there will be different protocols. Similarly, not just on the devices, depending on the type of communication. If the two computers are communicating for web pages, they will use HTTP or HTTPS protocol. If we are transferring files, we will use file transfer protocol. If the two computers are doing audio call, audio call will use different protocol. If two computers are doing, for example, sending emails, emails follow a different protocol. So there are many protocols based on the type of communication, based on the type of medium which is used between the devices. One example is HTTP protocol. It stands for Hypertext Transfer Protocol. That means it's a protocol to transfer hypertext. What is hypertext? Any idea? What is hypertext?
No idea.
Hypertext is basically text which contains pictures or videos inside it. Your web pages are made of hypertext. So this is a protocol to transfer your web pages, your internet pages. And then what is HTTPS? The same protocol, but with SSL encryption, that is protection. The packets will be protected before we send them on the internet. Similarly, we have file transfer protocol, we have FTP. There will also be another one which is called FTPS. That is the same file transfer protocol, but with added encryption, added security. You get the point, everyone?
Yes.
Okay, so these protocols, these are at the top level. That is, they are used for different type of applications, for web page, for files and other things. But the most important protocol in the internet is basically the TCP IP protocol. What is the purpose of this protocol? The purpose of TCP IP protocol, I will just write it in simple words. So TCP IP protocol, the purpose of this one is how to find devices on the internet. This is the main task of this protocol. What are the rules we have to follow in order to find devices on the internet? We will see how we can do that. But before we go into TCP IP protocol, first we will just quickly see how the internet, once again, it's a network of networks. And how do we manage? It is managed using different level of management. We have, first of all, what is called the internet service providers. Internet service providers, these are the companies which will offer internet access to users just like us, to businesses and other small ISPs. For example, in the kingdom, we are getting the network connection, the internet connection from which company mainly?
Maybe STC Mobile.
Exactly, STC, Mobile, Zen. So those are basically our internet service providers. These are our ISPs. And these ISPs, they are maintained, they are connected to what are called network service providers. Network service providers, they are responsible for giving the network service to multiple countries within a region. For example, within Middle East, we will have the network service providers, which is giving the network service to all the different countries. And these network service providers, they are connected to other network service providers. For example, Middle East network will be connected to the Europe network, to North America, South America, Africa. They will be connected through what is called the network access points. What are network access points? Those are basically network level routers. Remember, who is doing the interconnection of the networks? It's basically, once again, the same device, that is the router. Agree?
Yes.
Yeah. So these network service providers, they are tied together by the network access points. Network access points are basically the routers which are interconnecting one region's network to another region's network. So this collection of NAP and NSP, they create what is called the backbone of the internet. and how they are interconnected through submarine cables, and the companies which are responsible for managing those backbones of the internet, they basically charge you for the internet based on this. So there are companies like AT&T, Verizon, even Google and Facebook, they are also now in the management of these backbone of the internet. You can watch this video also, how the data travels across the internet. It's like 5-10 minutes video. It's very useful. You should try it later on. So that creates what is called the backbone of the internet. But now I want to go back to this part, that is the TCP IP protocol. That is the main protocol that we use on the internet. So what is this protocol? Once again, I told you the purpose of this protocol is to how to find the devices on the internet. If you want to go to, let me ask you a question. If you want to go to meet a friend in, let's say, Riyadh, you will ask for what? You will ask for his address, right? You will ask, okay, what is your address? You will say, okay, house number this, okay, street number this area, like that. Agree?
Yes.
Similarly, in computer system, this protocol says that every device on the internet must have a unique address. Every time you connect to KFUPM, to your home network, to STC network, to any network, whenever you connect, you must have a unique address to identify you on the internet. This address, we call it what? We call it the IP address. And for example, in the trace command, the addresses that you were seeing here, when we go from source to destination, the addresses that you see here, those were basically IP addresses. So how do we represent IP addresses? So the method we use, once again, computer systems, once again, they are digital devices. Whatever information we want to represent them with, or we want to save them with, it has to be in the binary form. Remember in week 1, when I told you how to store information. When you want to store information in the memory, that is stored in the form of what is called bits and bytes. You remember that everyone?
Yes.
So information in the memory is divided into different blocks. Each block contains 1 byte, and 1 byte basically contains 8 bits inside. So now I will use these bits to represent addresses now. So if I have 1 bit, how many different addresses I can have? 2 to the power 1, that is equal to what? 2. If I have 2 bits, how many different values I can have? 2 to the power 2, that is equal to what?
4.
4. If I have 3 bits, I can have 2 to the power 3, that is 8 different values. So now I'm using the bits. If I have 1 bit, I can have 2 addresses. If I have 2 bits, I can have 4 addresses. If I have 3 bits, I can have 8 different addresses. If I have 8 bits, like we used in the memory to store data, I can have 2 to the power 8, 256 different addresses. So do you think 8 bits are enough to represent addresses?
Yes, it's enough.
No.
What do you think? Do we have just 256 computers on the internet?
No, much many.
No. So 8 bits are not enough. We needed more bits. You understand the point, everyone?
Yes.
Okay. So we needed more bits. So how many bits do we need? So here comes the first version of IP address, that is IP version 4. Here, the size of the address is how many? 32 bits. That means how many different addresses I can have? 2 to the power 32. That will be equal to, here the number is given, 4294, this one. So basically it is around 4.29 billion addresses possible. So I can ask you this question in two ways. I can ask you, what is the size of IPv4 address? What is the size of IP version 4 address?
4.29 billion.
No, that is the total addresses. If I ask you what is the size of IP version 4 address, it is 32 bits. Okay. If I ask you how many total addresses are possible in IP version 4, in that case, the answer is 2 to the power 32, which is 4.29 billion. You get my point, everyone?
Yes.
Okay, so we decided we have 32 bits, and that is how we will represent our addresses. But there is still a problem. So I'm using 32 bits to represent my addresses, but these 32 bits I cannot memorize. If you are making a website and you want to tell someone, okay, my website address is 101000101010 like this 32 times. No one can remember it, right?
Yes.
So representing address like this was a problem. So what we did, these 32 bits, we divided them into 4 equal parts. So each part is basically called a segment. Each part is called a segment. Now, in each segment, how many bits will be there? If I divide 32 bits into 4 parts, equal size,
8.
how many bits in each? 8. 32 by 4, 8. So 8 bits in each segment. So if I have 8 bits, how many different addresses or different values are possible in each segment?
Maybe 256.
Exactly. If I have 8 bits, so that means in each segment I can have 256 different values, right? Now, another question is, for each segment, I can have 256 different values. I have to decide now which 256 different values should I use. Should I use letters ABC? Should I use capital ABC? Should I use numbers, positive numbers 0, 1, 2, 3 up to 255? Should I use negative numbers, negative 1, 2, 3? Should I use real numbers 1.1, 1.2, 1.3? So what numbers should I use for these 256 different values? So in IP version 4, the decision was we are going to use whole numbers. So you know what are the whole numbers, right?
Yeah.
They start from where?
0.
0. So that means my first number is 0. My second number is 1. If I keep on doing that, what will be my 256th number?
257.
50,
Not
57 or 55?
255.
5. Because my first number is 0, because 0 is included. That's why my 256th number will be 255. That means each segment, now we come back to the slide. So that means in each segment, we can have a number from 0 to 255, and they are separated by dots. Everyone, do you get this?
Yes.
Okay, I can ask you a question. Okay, which of the following is correct IPv4 address? First one, is it correct?
No.
No, because of
58. 250.
258. Second one, is it correct?
Yes.
No, look at the last part.
Yes.
It is 260. What about the third one? Wait. What about the third one?
It's okay.
Yes,
It's
it is correct. Fourth one is incorrect because of 1100. So you get my point, everyone? So
Yes.
Yes.
Yeah.
how can you check the IP address of your computer system? You can run this command, that is ipconfig/all. So if I run this command, or let me just run simple ipconfig, let's see which one I will get. Sorry. So here, there are different addresses I'm getting, IPv6 and so on. I will talk about them later, but right now, this is my IP version 4 address. Can you see that one, everyone?
Yes.
So using the ipconfig command, you can check the IP address of your computer. Now, we come to another problem with IP version 4 now. So notice IP version 4, how many bits we have in the address total? 32 bits.
32.
Agree? Total addresses possible around 4.29 billion. That's a lot of devices, a lot of addresses. But the problem is the new technology where we are moving to, that is IoT. What is IoT? Internet of Things. What's the idea behind IoT? Anyone?
Connecting things around us with us.
Connecting your daily life things also to the internet. The light bulb you use at your home, the home alarm, okay, the home security system, the washing machine, the kitchen appliances, everything in your home will be connected to the internet. And what was TCP IP purpose? TCP IP purpose was that
To find the
everything must have a unique address. So when we are connecting more things, that means we need more
address.
addresses, right? So there are two ways to solve this problem. That is one method to solve the problem is to use IP version 4, use the IP version 4 more efficiently. Or the second option is to shift to a new version, which is IP version 6. The new shift, I will talk about it next time. Right now, I will talk about how we can use IP version 4 more efficiently. Is it okay so far?
Okay.
Okay, so one method to use IP version 4 more efficiently is using dynamic and static IPs. The other way is to use private and public IPs. So first, let's see what is dynamic, what is static IP. What do you mean? What do you think means by static?
Can be changed or it's still.
Static is still, it cannot be changed. Dynamic is something which can change, right? So think of it in this way. Let's say if I am the service provider, let's say I am STC company and there are 50,000 customers in Dhahran region. So that means my company needs to provide 50,000 IPs to every device in the Dhahran region. Agree?
Yes.
Yes. But instead of getting 50,000 IPs from the internet, it will cost me a lot. What I can do is I can do some analysis. I can check that, okay, what are the maximum number of users online? If I make the analysis and I check that, okay, maximum maybe 30,000 are active. So what I will do is as an ISP, I will get only 30,000 IPs. When one computer turns on, I will give IP address to that computer. When it switches off, I will give the same IP to a different computer. When that switches off, I will give that IP to a different one. You get my point, everyone?
Yes.
So this dynamic assignment of IPs, we call that dynamic IPs. This can be assigned by the service providers, ISP, It can also be done by the routers. The routers can do another one. So fourth property of the router, they can do dynamic IPs using a protocol, which stands for Dynamic Host Configuration Protocol. This is a protocol used to assign dynamic IPs. For example, let me see here if it's in the details or not. Let me write it again, /all. So here, for example, this is my IP version 4 address. And notice here it says DHCP enabled is yes. Can you see this, everyone?
Yes, yes.
Yes. So that means this IP address, I got it dynamically from the router. When did I get this IP? Lease obtained here. I got it today at what? 12:43 p.m. When will the lease expire? On tomorrow, Thursday, February 1. You get my point, everyone? So this basically the home users, we always get dynamic IPs. Then the question is, where should we use static IPs? And what are static IPs?
I think for servers, main servers.
Exactly, for servers or websites. I don't want their address to change. That's why there we will use static IPs. Is it okay, everyone? So this is one method. This is one method to use IP version 4 more efficiently. Another method is to use private and public IPs. So another thing I will show you here is this. So this is my IP version 4 address that I got from the ipconfig command. So this is my IP address, right? I told you every computer has a unique address. Okay, so now let me ask Google. Let's check with Google my IP address. So when I search this, and it will open up this website. Let's see what is the IP address that I'm getting here. Everyone, can you see this address?
Yes.
Is it the same as the address I'm getting from ipconfig?
No.
No. So ipconfig is giving me this address and Google is giving me this address. So what's happening here? Any idea?
Maybe
What do you think?
the system making them equal.
Equal? No. So every computer, now I will give you a new definition. So every computer will have two addresses now. To make use of IP version 4 addresses more efficiently, we are going to change some definitions here. So every computer will have two addresses. One is called the private IP. The second one is called the public IP. What do you think is the purpose of private IP? Any idea? What is the purpose of private IP? Private
Maybe
IP? Yeah, what do you think?
in small networks, in local
Small network, not just small. For basically the name private means what?
privacy for yourself.
Privacy. For private communication within a network. For example, I'm right now I am in my home network right now. Remember who created my home network? Which device was responsible for the router, right? So when the router creates my home network, it will give me a private IP, this one. This private IP I can use for internal communication between my laptop, my smartphone, for internal communication only. Okay. Now, Remember, the router is also connected to the ISP, to the STC, right? So the IP address that we get from STC, that IP address we use to connect to the internet, that address is basically called our public IP. So if I ask Google, what is my address? This is the address that my router is getting from STC. So this is my public IP. Think of it in another example. Let's say, I will give you another example here. So this one. So here in this example, for example, in KFUPM network, we have different departments, Prepare, ICS, EE, mechanical, and they are all interconnected with each other through the router. So the routers which are building this network, which are managing this network for internal communication between the devices, between Prepare, ICS, Prepare, electrical, between a computer in the Prepare department, and if you want to go to Blackboard, which is our internal website, for Portal, which is internal website. So if I want to do all this internal communication, the IP address I will use will be called my private IP. Is it okay so far?
Yes, okay.
Okay. Now, what ITC has done is that in our IT department, the router, it is connected to the internet. Here in this diagram, I'm showing you only one connection, but actually there can be 3-4 connections. In case of KFUPM, last time I checked, there were around 6 connections to the internet. Those are basically our public IPs or external communication connections. What happens when a computer in prep department wants to talk to computer in ICS? This is internal communication, completely private, and I will use the private IP. No one on the internet has any idea what I am doing internally here. Now, another situation is if the Prepare department, I'm using a computer system and I enter gmail.com, or if I enter amazon.sa. Now, amazon.sa, it's a public internet website. Agree?
Yes.
So this request will go from prep department to ITC. And from ITC, this request will go to the internet. So according to internet, we have in this diagram, we have just one computer because I have connected one public IP to the internet. You notice that? So according to internet, we just have one computer system. That's why we have just one public IP. Internally, I can have thousands of devices which are communicating with each other with the help of private IPs. So private IPs inside a network, they will be unique. Every computer in ITC, mechanical, electrical, they will have different IP addresses for private communication. But what do you think the public IP? Do you think we will share the public IP? All the devices here, when they want to go to the internet, they will do what? They will share the public IP?
No.
Yes, because we have only one connection to the internet. You see that? So when any computer wants to go to the internet, they will use the public IP. Public IP is shared between the internal devices of the network. Same thing in case of the home network. Let me show you the home network here now. So here, if I have a router, and here instead I have a laptop here, I have a smartphone here and other devices. Each of them will get a different IP version 4 address for private communication. But all of them are getting one IP from STC. Which IP is that? That is this one. So whenever I want to go to the internet, I will use that IP. My laptop will use this IP. My smartphone will use that IP. Any other device in my home will use that public IP. So public IP is shared within the internal network. You get the point, everyone?
Yes.
Okay. Now I have two questions, very important. It will help you understand private and public IPs in a better way. First thing, in a private IP. So first thing is, we saw that what is the addresses, total addresses we have in IP version 4. We have in each segment 0 to 255, 0 to 255, 0 to 255, 0 to 255. Agree?
Yes.
This is the IP version 4 address range we have. Now, my question is this. Can the address that we use for private communication within internal networks, can I use that IP on the internet for websites?
No.
No. Why no?
Because it's private for you, not for.
This is exactly, it is just private. It is not a public IP. So the addresses on the internet, remember, they are all public IPs. You cannot use those addresses for private communication. But these are the total addresses I have, right? So what we do is, in IP version 4, we remove some of the addresses from this range. We say that one address range starts with 10. The remaining 3 segments can be any number from 0 to 255. Another range starts with 172. The second part is a number from 16 to 31. And then the remaining 2 segments can be any number from 0 to 255. And then the third range of address is 192.168. And the last 2 segment can be any number from 0 to 255. So what we do is, from the total internet address space, I remove these 3 ranges and I call them the private IP ranges. I will use them for internal communication. This one is for large private networks like KFUPM. You will see that if you come to class next time, you will see that if I run ipconfig command, I will get address something like this, 10 dot something. This is for medium-sized networks, medium private networks. And this third one, this is for small private networks, like, for example, a local area network or at home. Did you notice the IP address I got in the ipconfig command? You see this IP address, IP version 4 address that I received. Do you notice it falls in which range?
In small.
The small range. Agree?
Yes.
So these are the addresses basically we removed from the total addresses we have. The remaining addresses, we use them on the internet. Do you agree to this, everyone?
Agree.
Okay. Now, please pay attention. So remember, my goal was to use IP version 4 more efficiently, right?
Yes.
Okay. So the total addresses on the internet, by doing this, the total addresses on the internet, they have increased or decreased?
Decrease.
Decreased. Okay. Total addresses have decreased now. So what's happening? My goal was to somehow use them efficiently, and I have ended up decreasing the total number of addresses on the internet. What's the catch? What's the advantage of doing this? So remaining addresses, once again, those are public. So now I will give you the second question. The second question will be based on this diagram. Where is it? This one. So here now, think of this diagram. We have the internet here. We have a private network. Let's say this is KFUPM. If I ask you a question, what is the public IP of user 1 in this network? What is the answer?
191.11.
Yeah, exactly. 191.11.12.1. Okay. If I ask you, what is the public IP of this user in KFUPM?
Same.
Same answer. If I ask you, okay, what is the private IP of this user 1? That is this one here, right?
Yes.
Okay. So let's say this is KFUPM network. And now let's say this is another university. Let's say this is KAUST University network. Now, again, I ask you the question, what is the user 1 address, the public IP in this network? 11.11.12.1. Similarly, what is the public IP of this one? Also 11.11.12. Now, my question is this. Can user 1 here know the private IP of user 2 in KAUST University?
No.
No. For us, what is the IP address of every computer in KAUST University?
It's 11.
It's the public IP, right?
Yes.
We have no idea what is inside. Agree?
Yes.
The same goes in the opposite way. In KAUST University, no computer has any idea what is the private IP of this computer or this computer in KFUPM. According to KAUST University, all the computers in KFUPM, their IP address is this one. Agree?
Yes.
Yes. So now comes my question. The question is, can the private IPs that I use for internal communication here, can I use the same IP addresses in other private networks? What do you think?
Yes.
I think no.
Why no? Remember, in any private network, whenever you go to the internet, you have to use public IPs, right? What is happening internally, other networks have no idea. Do you agree?
Yes.
KAUST has no idea what's happening internally here. KFUPM has no idea what's happening inside KAUST. So for internal communication, we should be able to repeat these addresses because when we go to the internet, we will use the public IPs. You get my point?
Yeah.
Yeah. So this is where we get the effectiveness, the usefulness of doing all this. What is the advantage now? Although I removed some of the addresses, now comes the advantage part. The advantage part is this. I want to build two networks. One has, let's say, 5,000 devices. Another one has, let's say, 10,000 devices. If there was no private public idea, how many IPs I need? IPs
15.
needed from the internet, that is 15,000, right? Agree?
Yes.
Yeah, but now using public-private idea, what I can do is I will only get 2 IPs from the internet. What I will do is with one IP, I will make a large private network of, let's say, 5,000 devices. What will I use for their internal communication of 5,000 devices? For them, I will use the private addresses, right? But whenever they want to go to the internet, I will use that one public IP that I purchased. Similarly, the second IP that I purchase, I will make another private network of 10,000 devices. And when any device wants to go to the internet, it will use the second public IP. So using only two IPs from the internet now, I am able to handle 15,000 devices. Do you see the advantage now?
Yes.
Okay, so this is the main property of these private and public IPs. Another thing is called network address translation. Netting is basically in these networks, the routers, when the packet comes back from the internet, it is coming back to this address, right? The public address. How can we know that the information coming from the internet, is it for this user or this user or a different user? So this is done by the router using a method which is called network address translation. So it uses this method to translate between public and private IPs. The router will keep a table that, okay, this website data was requested by this user or this user. So when information comes back, it will send it back to that user. You get the point, everyone?
Yes, yes.
Okay. So before we exit, there's one last thing, that is DNS. But first, let's see some example. Which one do you think? This is a private IP or public IP?
Private.
Private,
Private.
because it starts with
Private,
10.
yes.
Other numbers can be anything, it's fine. The second one, private or public? The second address range, let me show you here. That is, it starts with 172. The second number can be anything from 16 to 31. The last two, anything from 0 to 255. So the second one, is it private or public?
Private.
Private. What about the third one?
Public.
Public.
Public. 15 is not in 16 to 31 range, right?
Yes.
Right.
So that is public IP. What about this fourth one?
Public.
Also public. What about the last one?
Also
Public.
public.
Public. For the small range, it should be exactly 192 and 168. Here it is 192 and 167. So this is also public. Now the last thing before we stop, there is an assignment also. So before we stop, I just want to do one thing. We noticed all the devices we are communicating with IP addresses, right? Websites, they have IP addresses. But when I'm using the internet, am I using these addresses? If I want to go to a website, do I type IP address?
No, you don't.
No. We type the names, right? We type names, amazon.sa, noon.com, okay? We type gmail.com. So what are these? These are called domain names. .com is called the domain, and this is called the name of a website. And what are domain names? They are just very simple. They are synonyms of IP addresses. They are synonyms of IP addresses. Because IP addresses still, they are difficult to memorize. If you want to tell someone, okay, I made a website, this is my IP, 192.167.255.123. It's not easy to memorize, right? So domain names, they are, once again, they are synonyms for IP address. So there are different domains like .com, .edu for educational websites, .org for organizations, and then there are subdomains also. What do you mean by subdomains? The .edu is the main domain. .edu.sa will be subdomain for country specific website. Agree?
Yes.
So whenever you want to go to a website, remember in the packets I showed you, the packet contains data and address. And the address it contains is the IP address. So if you want to go to Gmail or any website, you first need the IP address. So how to get the IP address? We get it from a system in the internet. We call that the DNS servers. What is the purpose of DNS servers? They translate domain name to IP address. So this is the summary I will show you now in this diagram. So when you want to go to a website, let's say you type Amazon, let's say you type Gmail. When you make a request, your information will not directly go to the internet. First, you need to convert the domain name into IP address. So this request goes to the DNS servers, the domain name system servers. You will check in KFUPM private DNS server or the public DNS server, but the idea is to get the IP address back. Once I get the IP address, now I can put it on the packets and then send it on the network for communication. You can access the DNS servers also using a command called nslookup. If I say nslookup space amazon.sa, what it will do is it will return me these IP addresses of the website. And what do you think? Can you access the website using just the IP address?
I think yes.
It should be. Let's see. Yeah, there will be some security error because we are trying to access directly with the IP address. Yeah, the website is not allowing, but we should be able to access that. Let's try it for Google. It should be do that. So Amazon is not allowing us to access from the IP address. Let's see for Google. So I'm getting this IP address here. So let's see if we are able to access. Yeah. So here you see, if I enter the IP address, I am able to reach Google as well. So using IP addresses, I can convert domain name to IP address using nslookup command. So I'll stop here. There is a small assignment that you need to do. So the commands that we have seen is ipconfig to check our IP address. Another question, ipconfig gives us the private IP or public IP of my computer?
A private.
Private IP, exactly. And we have nslookup commands. It converts domain name to IP address. We have trace command, trace RT. It gives us the IP address from all the links from source to destination. So using that, you need to answer these questions given. IPv6 we will discuss next week, but you need to answer these questions given in slide number 34. So what is network interface card? Their answer is in the manual. Then how to trace the path to amazon.sa, find the private IP of your computer, public IP, and so on. What is the IP address of Noon? So very simple questions. Try to answer them and send them in the assignment before the next class. Is it okay, everyone? I will just create the assignment now.
Okay.
Okay, so I'll stop the sharing and the recording. And for those who missed the lecture, let me